Well, this is actually a little bit more complicated. There's a paradox called Russell's paradox, or the paradox of the barber. It was invented in 1901 by Bertrand Russell, an English philosopher and mathematician. This is how it goes. In a country where every man is shaved on a daily basis, there is only one barber. He shaves all the men who do not shave themselves. But here's the paradox. Who shaves the barber? If we analyze this using set theory, we can see that in this country, there is the set of those who shave themselves and those who are shaved by the barber. Does the barber shave himself? That's impossible, because he shaves all the men who do not shave themselves. Does someone else shave him? No, because the barber shaves all those who do not shave themselves. Paradox. According to Russell, to overcome this problem, we must correct our false thought that for every property there must be a set. In this case, there is no set which doesn't have common contents with another set. In other words, there is an intersection. But let's get a little bit deeper. What the paradox is saying is that there can be no set which contains all the sets there are, because if there is such a set, it must contain itself. But then it is impossible to prove that, because in order to do so, we are forced to use as proof the same thing we are trying to prove. On the other hand, if we accept that the set does not contain itself, therefore it does not contain everything, then we can indeed prove it, but there will be a component that will be left outside our system, and therefore our proof will not be complete. In other words, if our system can indeed be proven, it will not be complete, and vice versa. If our system is complete, it cannot be proven. Therefore, if the paradox exists, then our system cannot be proven, and we can conclude that the paradox does not exist. The other way around, if the paradox does not exist, then our system can be indeed proven, and we can conclude that the paradox truly does not exist. Either way, we can see that the paradox does not exist.